Hello, everybody, and thank you for joining us today to learn about how to get an order of magnitude greater software productivity, presented by Mike Stonebraker, DBOS co-founder and CTO. Our agenda today, I'm just going to do a quick introduction of DBOS, then I'll turn it over to Mike to talk about how to increase your software engineering productivity by 10x. And then our head of customer solutions, Alex Polyakov, will do a quick demonstration to show you, to illustrate a lot of the concepts that Mike explains in his talk. And we'll wrap up with some Q&A. Okay. So for those of you who don't know, aren't familiar with DBOS, it was the company was founded based on several years of research that Mike led from MIT with a team of MIT and Stanford researchers into a new platform for cloud computing. All of that led to DBOS, and DBOS that makes it much easier to build cloud backends, essentially. Right. It starts with DBOS Transact, which is an open source framework for TypeScript developers that greatly simplifies backend development. It makes applications reliable and observable by default. DBOS Transact applications can be deployed to run on Windows, Linux, Mac OS, and of course the DBOS Cloud. The DBOS Cloud, which runs on Amazon, is essentially DBOS Transact as a service. It's where you can host and run your Transact applications and workflows, and DBOS Cloud will automatically scale those based on demand in real time. It will do things like automatically restart anything that crashes or goes sideways and resume where it left off. It's a big part of the reliability, and also helps to make them disaster and cyber resilient through application and database restoration at specific points in times. It also enables a capability that we call time travel, right? And you can use time travel to facilitate the troubleshooting of applications and auditing and things like that. It essentially allows you to look at the state of your application at any point in time and debug your code as it ran at that point in time. You can also use time travel to roll your application back to a point in time before a cyber attack or database corruption or some other disaster. Okay, so that's DBOS in a nutshell. And now to explain that, provide a deeper dive on that and explain a little bit about why it was developed, I'm going to turn it over to the creator of DBOS and DBOS CTO, Mike Stonebraker. Mike?
Thanks, Andy. So what I want to talk about is how to get an order of magnitude in software productivity. That means you'll take 90% less time to do a particular class of applications. Now, with this title, you're probably expecting some magic ChatGPT thing to be the topic of conversation, but that's not true at all. So most of you should be using Copilot. If you're not already, please do. And it's worth, I've talked to lots of developers who all claim it's worth 30–40% in productivity. So by all means, get that improvement. But what we're going to talk about is an order of magnitude, which is, a factor of 30 or 40 more than Copilot is worth. So stay tuned and pay attention. So next slide. Now there is a little context. First of all, everybody on the planet is moving everything possible to the cloud as quickly as possible. Unless you've been hiding under a rock somewhere, you're well aware of this. And why is this happening? There's two big reasons. One is cost. It's cheaper. And I have a big caveat here, which is unless you cheat. Now, I'm a member of a lab at MIT, and the lab runs a data center. And the person running the data center claims that he can run the data center cheaper than Amazon can. And he's correct, because he does not pay for electricity and he does not pay for floor space. So, he's only counting some of the resources that the rest of us would have to pay. So unless you have a rigged financial system, it is cheaper to run stuff on the cloud. But the bigger savings is that if you're running on-prem, you have to provision for the maximum load. And if you're running on the cloud, you can have 20 servers at the end of the month and 3 servers during the middle of the month. And so you only pay for what you use. So huge savings in provisioning. And so these 2 reasons are moving everyone to the cloud. Of course, the cloud will be resisted by your internal IT folks who see this as threatening their job longevity. But in any case, you're all going to the cloud as quickly as possible. So now, if you take a look at the cloud, unless you're hiding under some rock, you're highly encouraged by the pricing strategy of all the major cloud vendors to structure your application as a directed graph of operations. Call them micro operations, steps, whatever you want to call them. And it's a directed graph, and you're encouraged to pass state between operations, either through storage or as parameters to whoever's coming next. If you do this, you only get charged for computing when you're active. You're not running a server. You don't get charged all the time. So this will make things much cheaper on the cloud. And if you want an example of how to do this sort of stuff, think AWS Lambda and step functions, who are early examples of doing this. So think software as a service, think function as a service. Anyway, you are highly encouraged to adopt this computing model. Okay, so assuming you buy the 2 slides that I've just said, let's look at an example of a data-oriented application. So all of us use the web, and if we're buying anything, on every website that we can buy stuff on, there's a buy button. So what's the code behind the buy button? Well, here's just an example of what you may well have to do. It's probably more complicated on real purchases, but this is enough to illustrate the issues involved. So if I hit the buy button, I want to buy I want to purchase 3 widgets. So the first thing that has to happen is I go off and attempt to reserve 3 widgets from inventory. So I need to put a hold on 3 widgets. Now we're assuming that you're not allowed to sell stuff you don't have. So you don't get to do what Amazon does, which is usually ships within 24 hours. So you got to reserve inventories. So assume you can only sell stuff you have. So assuming that the inventory is there, then you check the customer's credit to see if you want to do business with him. Assuming that's okay, you then take his money to pay for the 3 widgets. Assuming that works out okay, then you've got to do fulfillment, which is actually ship him the 3 widgets. And that's an example of the forward control flow, which is the buy button is these 4 steps. And if all of them succeed, then you've sold the guy a widget. Okay, so simple enough. I want to just note that as often as not, these blue boxes may well be services that you're not coding, which is check credit. You may well deal with an external service. Process the payment for sure is likely to be an external service, and so forth. So as often as not, these are boxes that you call as services that you don't control. Next slide. Okay, so the forward logic is pretty straightforward. The issue that's really tricky is what do you do with errors? So if you can't reserve the inventory, you don't have 3 widgets in stock, what do? Well, you got to process the error. It probably means backing out the entire interaction. If there's a credit check failure or a payment processing failure, again, you've got to handle the error. And then if you get all the way down to fulfillment, if the user's given you a bad address, then you can't possibly fulfill the order and you got to do something. As often as not, what that will mean is backing out everything. So basically what you're looking at is you've invoked a collection of often external services. Presumably they are implemented as transactions. So you've run 4 transactions and the final transaction fails. In that case, almost certainly you want to back everything out. So the error branches are where a lot of your code goes. Next slide. If you want to make things really hard, then as Andy Ellicott said, what happens if you crash? So your server goes down and it gets restarted, and now the question is you have to pick up the pieces. If there's a disaster, and they don't happen very often, but if AWS experiences disaster, then everything is down perhaps for an extended period of time, which is you don't get back up again right away. And the worst case of all is there's a ransomware attack, a successful one, and all of a sudden you can't get at any of your data. Well, again, you have to pick up the pieces. And then the last thing is, if all of a sudden you get a whole bunch more load, then whatever you're running becomes overloaded. And again, you have to do something. So there's load balancing and reactions to load. You have to have load elasticity. So this is the oops logic, which is bad things can happen. And again, you have to pick up the pieces. So these are the challenges, which is the error logic. The forward logic is fairly straightforward. It's the error logic that's complicated. Next slide. Now, early users of DBOS report to us that the forward logic is about 10% of their effort, and the error logic and the oops logic is 90%. So you shouldn't worry. You should worry more about the error logic and the oops logic then you should worry about the forward logic, because that's not the high pole in the tent. So now I'm going to tell you how DBOS gets rid of most to all of the error logic and the oops logic. Next slide. So we make a collection of guarantees. We give you a workflow model. So if you want to use DBOS, you've got to structure your app as a collection of workflow steps arranged in a directed graph. Right now, we ask you to code those workflow steps in TypeScript, but we will probably, over the course of time, support a bunch of other programming languages. And so the first guarantee you want is what has come to be called by practitioners once and only once, which is no matter what happens, you don't want to charge the customer twice or ship the product twice. So you want to do things once and not more than once. Now, one regional bank that's here in the Northeast estimated that 40% of their code base is there to implement once and only once. So this is a lot of logic if you have to do it yourself. Because to a first approximation, you got to keep track of a whole bunch of stuff and pick up the pieces on errors, which means doing the right thing when you're in danger of shipping twice or paying twice. So DBOS gives you a guarantee that we do things once and only once. So workflow steps will never be done twice. Second thing we guarantee is what the database community is called sagas. Now, this is an old concept, originally proposed by Hector Garcia Molina back on, I believe in the 80s. And so what you want to do is you have a collection of transactions, and if there's a bad address at the end, you typically want to unwind everything. Now, sometimes you can just do physical backout, which is take the log of what you did and reverse it. Pretend this is a crash and back out. Unfortunately, that often doesn't work, because if you've reserved inventory, well, you subtracted 3 from the number of widgets. The compensation is to add 3 back. So the compensation for subtraction is addition. So compensating actions are often just not physical backout. You need to actually propose a compensation. So database sagas are the idea that for any transaction, you have to tell the system what the compensation is. Sometimes it's just physical unwind, and sometimes it's a compensation. So the guarantee that DBOS gives you is that if you buy into our sagas, then we will guarantee that when bad things happen, we do the right kind of unwind. And so we restore a consistent database that looks like your saga never took place, or if you want some other compensation, we will execute that compensation. Third guarantee that we give you is that you have this graph of operations. You want the graph to finish even when bad things happen. So if you ordered 3 widgets then if everything goes okay, you want to make sure that you actually get your 3 widgets, even if bad things happen. So even if there's a crash or a ransomware attack, which is to say workflows are either done or they look like they never started. Everything is done once and only once, and we support compensations. Okay, we give you all of these guarantees for any workflow that you give us as long as you buy into our model. Next slide. So if with these guarantees, you write the forward logic and the platform handles everything else. Now, there is a little bit of sneaky stuff going on, I have to admit. First of all, we deal with database-oriented applications. So the state of your application has to be recorded in the database. So any state you have, put it in the database. That way, with careful bookkeeping on errors, we can pick up the pieces correctly. The other thing we do is, since you give us the workflow, orchestrating the workflow, which is to run the operations, when inputs are available, we handle all that. So you don't need to worry about orchestration. We do careful bookkeeping to support once and only once. If you give us compensations or tell us that physical backout is okay, we will do that if bad things happen. The last thing was mentioned by Andy at the beginning, which is we time travel everything. So what that means is that whenever you put anything in the database, we will actually consider that an event, and we will log that event to a data warehouse elsewhere in the cloud. And so with this event database, we can back up everything. And when I say everything, I mean the orchestration. Orchestration is also in the database. So all events that deal with the platform go into the database and are logged to a data warehouse, and you can keep this log for as long as you're interested in paying for storage. So what that means is that if there was a ransomware attack 17 minutes ago, you can just back up everything 18 minutes and then single step around the bad guys and then roll forward, and you're now back up and running transactionally, even if there's a successful ransomware attack. So time travel means we can back up if something really bad happens and then replay forward. Also, as Andy said earlier, we give you load balancing. So if you're running on 3 of our servers and one of them gets overloaded, we rebalance. If you don't need 3 servers, we get rid of 2 of them and you're running on only 1. So we do scalability automatically. We do load balancing automatically. We do careful bookkeeping, so you get once and only once. We do orchestration, and we make sure that the error logic is done correctly without you having to do anything. So you write the forward operations, and you give us a little bit of extra information, which is you define what undo means, i.e. you are willing to deal with sagas, and you put all your state in the database, then you just write the forward operations and we handle everything else. There are a couple of caveats. So caveat number one is if there is, a network partition, then we can't guarantee these steps until the network gets put back together. And there are a couple of other caveats that I'm happy to talk about if people are interested. So there are a couple of caveats, but unless there's really very strange error conditions that happen very, very, very rarely, we make these guarantees. So you write 10% of the code and we automatically do the remaining 90%. So this early DBOS users have reported that it's an order of magnitude. Your mileage may vary. It may be 95%, but it's a big number. So that's what DBOS does for you. And this is why you get to write vastly less code. Okay, next slide. Now there are some other goodies that I want to just mention. First of all, if you're writing your application, these workflow steps, well, the problem is any of you who have written software as a service applications know that it's pretty tricky to debug parallel execution, which may well happen. So if parallel operations are hard to debug, so if we can time travel everything, then we can certainly time travel your application. And so we can back up your application and then single step around and or change stuff, insert changes to the data and so forth. So we give you a time travel debugger so that you can get even more productivity improvement by getting a very fancy debugger. Second thing I want to mention is that this is for database applications. So we co-locate the DBMS, your operations, and the orchestration. So in most systems, your application runs somewhere other than the database system, and orchestration is running yet some third place. So that's expensive in messages. And by co-locating operations, we give you much higher performance. So we store your processing steps, are stored procedures in the database. Now, under ordinary circumstances, if you use stored procedures as they come out of the box with something like Oracle or Postgres, well, you have to code in stored procedure talk, which is something like PL SQL. Well, no one wants to do that. You don't want to have to learn a new language to be able to get performance from co-locating code and data. So we allow you to write your operations in TypeScript, and we deal with moving them into stored procedure talk. So we give you performance by co-locating stuff. We give you more productivity by allowing you not to have to code in some strange language. And we also give you a fancy debugger. Because of this stuff, it should surprise no one that we are an order of magnitude cheaper / faster than AWS Lambda. So any of you who are peeved that Lambda is so expensive, well, come check us out. As the graph shows, the blue stuff is us, the orange stuff is Lambda, and we're well more than an order of magnitude faster, more like 2 orders of magnitude faster, slash cheaper. So other goodies, we give you a better debugger. We give you high performance from colocation, and we give you, it's cheap. So next slide. Now, one thing that comes for free, which some of you may be concerned about, others may not be. So security is in general a huge deal. Most everybody, I heard, a story yesterday about this was an MIT professor whose father-in-law ran a beer importing business in Florida. And it's something like $10 million or $20 million a year in revenue. It's not a giant business. So they didn't pay much attention to security because they said, who's in the world is going to attack, a small time beer importer in Florida? Well, guess what? A successful ransomware attack occurred, and like everybody else, they paid off the bad guys to get their data back. So security is a big problem. A lot of you ignore it until you have a disaster, and then you say, oh my God, why didn't I think about this earlier? Well, DBOS is a great deal safer system than whatever you're doing now. The reason is, first of all, we don't run on Linux. We don't run on Kubernetes. So two big vulnerable attack surfaces are gone. Secondly, we run stuff in the database, and so us and the database system are the only things running. So you don't have a myriad of other stuff to configure that gives you a bigger attack surface and configuration vulnerabilities. And so we are more secure. And then, as I've said already, if a successful ransomware attack occurs anyway, you just back us up. We have a complete event history. We can do selective or full recovery to a point in time. So the frosting on our cake is you get much better security for those people who are interested in it now, and the rest of you will be interested in it once you've had a bad security failure. Okay, I think that might be the last slide. Oops, the summary. So what we give you is at least a factor of 10 productivity improvement on this class of applications. We don't claim an order of magnitude if you are writing code to print out Fibonacci sequences. So on data-oriented applications, you simply write the forward loop and we handle all the drudge work. Together with much lower cost and better performance against AWS Lambda and step functions, and increased security and resiliency. And so everything I've said, you can explore in detail by checking out our website, dbos.dev. And with that, I'll turn it over to Alex Poliakoff, who's going to show you a quick demo.
Hey, everybody. Great to see you. I recognize many of the attendees from the community. I emailed and chatted with many of you. Thanks for coming. So it's hard to follow Mike, always, but I'm very excited to show you what we have. This is a demo app I'll show you. So we have a whole repo of demo apps, and this app is called Widget Store, and it goes through the workflow that Mike mentioned in the slides. And this workflow looks like this. So an order comes in, we subtract the inventory and create an order. Then we check payment, and here we use a dialog because for a demo purpose, it doesn't make sense to call out to an actual payment provider. And then if the payment goes through, we fulfill the order and mark it as a success. Otherwise, we mark it as a failure and we um, undo the inventory subtract. So we increment the inventory back up. Just like Mike said, this is the compensating step. So this is pretty much all the logic you need to write. All of the oops things are handled automatically by DBOS. And I can crash this code at any point, and when the app is restarted, it will finish where it left off automatically. And you can download it right now, and you can deploy it to the cloud for free to try it out. So to get it in the cloud, this is really all you need to do to deploy. So we create a very easy to use CLI. You log in, you get a database. You can bring your own database and connect it to the cloud, register the app, deploy, and if you want a dashboard, you say this, and you have a dashboard where you can monitor your whole app as well. So the app looks like this. It's our widget store. I click buy now. At this point, the inventory went down from 5 to 4 because we're in the middle of an order. And if I confirm payment, my order is fulfilled. And now I bought one widget and there's only 4 left. If I deny payment, the order is canceled. So what I'm going to do now is put it into a state in the middle of an order like this. So now the inventory count is 3. And then I'll go to this special screen and crash it. And so now this feature isn't standard with DBOS apps. We added it as part of the demo, right? So now my app is stopped, and it stopped in the middle of an order. So let's take a look at what the dashboard says. This is the monitoring dashboard that you get in the cloud with all your apps. You can monitor things pretty much real time. This is the log from the app that's captured automatically. So you can see we had a payment successful, then a payment failed, and then this is our crash. And right away after the crash, DBOS Cloud restarted the app automatically. And after it restarted, it actually said, I am recovering a workflow here. So it knows that it's in the middle of a workflow, and it automatically goes into recovery. So if I go back and refresh the page now, I'm back to where I was. And if I hit deny payment, the order that I had was canceled, and I'm back to a consistent state with 4 widgets left, right? So all of the oops stuff that would be associated with the app crashing, that was handled automatically by DBOS. Conversely, if I hit back now and try to perform some other action and say confirm, it won't let me do that. So DBOS workflows happen once and they are unique. And once this workflow is complete, it won't let me change it again, as it were. This dashboard is also neat in the sense that I can go back to a particular point in time, say 9 p.m. yesterday, and zoom in on a particular time. And here I see all of the traces for all the workflows that ran. So this is 9 p.m. last night, and I can click on a workflow that I ran and say debug it, and that brings it up in our time travel debugger. So here's a breakpoint, and here we're going to add a query in the middle of the code. And I run through that, and it says that the inventory at this time was actually 9, right? So this is a select statement that we've added to say select inventory from products and print it out. And this is the time travel debug capability. So as I debug the code, I see the state of the database as it was at the time that this ran. And so this allows us really an excellent way to debug what happened in production, right? So, and you can add new queries to this code too and run them, right? So you can run arbitrary read queries when debugging past production traces with the database just as it was at the time. I can also do this with arbitrary queries. So this is something that Mike calls general purpose time travel. This is built on a component that we call the debug proxy, and I can connect to the proxy, and it looks just like a Postgres SQL connection. I can run a query to say something like select product inventory price from products where the product contains the word widget. And I see that right now I have 4 widgets in the inventory. So fair enough. That's the current state. Now I run something like this. So this sets the timestamp to 17th. That's yesterday at 10 a.m. Eastern time. I run that. And now I run the same query, and this query returns 12 widgets, not 4. So whether you are very interested in what your data was like at, say, the end of the month, last month, or you're doing a particular troubleshooting or something anomalous happened to your data and you want to go back to a particular point and run a query, you can do this here. And again, this supports any read query from your data, this capability. This is something that Mike likes to call general purpose time travel, right? So everything goes in the database. We can go back in time and we can view our data as of any point in time. And of course, a query like this, I can use this to query a few of the underlying provenance table to get a historic snapshot of everything that happens. So if I run this script, this gives me all the changes to my widget table. DBOS captures the IP address that originated the change, the timestamp. You can also have authorization middlewares and capture which user did a particular purchase, and so on. So, of course, we have time travel, being able to go back in time and being able to generate a history of all the events that happen. So this is kind of the key things that I wanted to show you all today, right? Obviously, we are there on Discord. You can try these capabilities right now for free in DBOS Cloud. You can start with up to 3 apps for free. And you can use DBOS Transact and run these on your own hardware pretty much anywhere. I think that's it from me, guys. Let's see if we have questions in the Q&A. And
Mike, probably for you. This person is assuming that our error handling techniques are more advanced than two-phase commits, asking what logic do we use for, I guess, the workflow guarantees.
Okay, so let's start with let's start with there's a database system behind the curtain. Right now, we assume that you were running a Postgres compatible wire protocol compatible DBMS. And that includes things like RDS. It includes things like Yugabyte DB, Cockroach DB, bunches and bunches of others. So they all support transactions, and we simply submit transactions to the DBMS that's behind us. If you want to use us, right now, we assume that you're running either Aurora or RDS, since those are the AWS preferred systems. But you can configure any Postgres compatible any Postgres wire compatible DBMS. And it will give you, and these vary with whether they are multi-node, multi-core, single node, and exactly what kind of support for transactions they have. Anyway, supporting transactions becomes the problem of the DBMS. And someday we will almost certainly write our own DBMS. But right now, we depend on some other DBMS to implement transactions. So then the answer is, if one of their transactions fails, then they pick up the pieces inside that transaction, and to then back out the rest of the workflow, we depend on compensations. So you need to tell us what compensation makes sense. You may put the item back in inventory, but charge the user a restocking fee, et cetera, et cetera. So the answer is, we depend on there being sagas. We implement the sagas as long as you specify what they are. And so that's what we depend on. If there's no such compensation, which is to say, if the ATM spit money out of the machine, there is no compensation for, put the money back in the machine. So there's some situations where compensations just don't exist, at which point, we can't help you. You're on your own. So the answer is compensations. Moving the money back in the reverse case, if it's an electronic transfer, then we just issue the compensating action. If money came out of the ATM, then you're out of luck. We can't compensate.
Okay.
Yeah.
Another question, probably for Alex. Person asked whether DBOS Cloud could support a scenario where you're running something on DBOS Cloud, but suddenly want to switch to self-hosting, presumably running DBOS Transact somewhere, and wondering whether state can be moved from DBOS Cloud to self-hosted DBOS Transact. I assume the answer to this depends on your definition of suddenly, but Alex, you want to?
Yes. So there's a couple of things to consider here. One consideration is that, of course, it's your database and you can always access your data. You can always do reads and writes from your database. Now, there's two ways to deploy in DBOS Cloud. One is we provision a database instance for you, but you have full access to it. Another one is you bring your own database to DBOS Cloud. We call that BYODB. And if you're doing BYODB, you maintain full control of all of your database, fine-tuning whatever you need. As long as it looks and acts like Postgres, we will support it, right? And the beauty of DBOS, of course, is that all of the state is in the database. So everything you need to continue execution is in the database. So if you were to suddenly need to redeploy somehow or access your data in some way or go back in time, the database is all you need to do it.
I think that's it. We're near the top of the hour, so I want to thank everybody for joining us today. Mike, Alex, thank you for your for sharing, and we look forward to seeing everybody on a future webcast, and look forward to an email tomorrow with a link to a recording of today's event and Q&A and some other helpful links. Thanks very much.